Hi guys, in this video we are going to look in depth on function calling and how NexusRaven-V2 13 billion parameter has surpassed the GPT-4 in terms of in the field of zero-shot function calling. We'll look at the features, then we'll go and have a look at this Google Colab notebook and see for ourselves how and why NexusRaven is superior to GPT-4. Let's get started, and I'm really happy that you have joined me in this video. So we have NexusRaven-V2, a 13 billion large language model which has outperformed GPT-4 in zero-shot function calling, the capability to turn natural language instructions into executable codes to use tools. Now, if it's difficult for you to understand the function calling and everything, fear not. In this video, we are going to go one step from zero to hero in just a second. The function calling abilities lies at the core of the OpenAI API assistant, we know that, and serves as a key to enabling copilots and agents to use software tools. Essentially, we know LLM, it has the capability to generate things because it has been trained on certain things, huge amount of data, but it doesn't have the capability, for example, to extract information, let's say real-time information, or updates which are just recent updates. So let me ask you a question. What is the weather of New York just now? What is the weather right now? The data for that is not available with a normal LLM. Now, in order to get the data, in order to produce an answer, the LLM needs something like tools. It needs some extra hands and legs to get the data, and to use those tools we need a way to get the output from the tools, and the way is function calling. One of the ways is function calling. So function calling is a process which lets the LLM use different tools so that the answers are more enhanced and reliable to your use case. Okay, so we'll go again more deeply into how we can do the function calling, but this is just for your start. Now, if we see the capabilities, state of the art and generalizable capability, NexusRaven-V2 surpasses GPT-4 by up to 7% in function calling success rates in human-generated use cases involving nested and composite functions. So we have nested functions, which means calling a function and then calling a function, using that result and calling a function. Composite functions are more complex functions. So NexusRaven has never been trained on the functions used in evaluation. Of course, you should use, for evaluation purpose, you should use cases which it has not been trained. Otherwise, what is the purpose of machine learning? It's an open source and commercially permissive. The NexusRaven-V2 is further instruction tuned on Meta CodeLlama's 13 billion instruct model. It leverages the curated data generated through the Nexus Flows pipeline and exclusively outsourced from open code corpora without using proprietary LLMs. It's commercially permissive for both community developers and enterprise. Ease of integration, we released open source utility artifacts that enable users to seamlessly replace mainstream proprietary function calling with NexusRaven-V2 in their software flow. We also provide online demos. Let's go and have a look at the demos and the Colab notebooks for onboarding and integration demonstration. Okay, function calling benchmark and leaderboard. If we go and look at the benchmark of function calling, we can see that it is far ahead of many of the even closed source models that we have. So we can see the capability NexusRaven in parallel callings and nested calls. In the single calls, it's almost similar to GPT-4, but in the parallel calls and nested calls, it is superior to GPT-4. And then we can see here average task. We have superior results for NexusRaven-V2 13 billion when compared to GPT-4, I don't know how much billion. So we go and have a look at the Python code on the Colab notebook. And again, refresh your memories, erase your memories, and let's get started. So we have opened this Colab notebook here, and welcome to Raven-V2. So the section introduces function calling and Raven. We are going to go very slow and understand each and every aspect of function calling so that you don't need to take or watch any other videos on function calling. This will be the end of it. Of course, the implementation for different LLMs will be different, but the general understanding and general topic and general knowledge with regard to function calling should be clear when you complete watching this video. So introduction. This document serves to walk you through Raven-V2, a fully open source function calling model. Not many models can give exact function calling. So what is function calling? Function calling as part of tool use by the LLM refers to the process where the LLM identifies and executes predefined functions with relevant arguments. So we would have a list of predefined functions that we would give the LLM that here you go, these 5 function calling functions are available, and you can make use of these functions whenever you deem fit and whenever you deem necessary. That is the whole work that the LLM has to do. The LLM has to understand the context. The LLM has to understand our users' queries, and come up with a solution using the tools that it has. So we are going to define the tools via the function calling with relevant arguments. This is a key aspect of how the LLM utilizes its integrated tools to effectively respond to queries presented by users. For example, if the input to a function calling model is a function to get the weather, for example, get weather, suppose we define a function where we can define this function, let's say get weather, and the city name is a string, and the user goes ahead and asks a question on the weather of Seattle. Then the LLM generation should be something like get weather and Seattle. So it will give me a response, a JSON response or a normal response of how to call that function. Okay, then we would take this thing and execute it. Since we have defined the get weather function somewhere else, which we will initialize before we run this LLM, then it is going to run this syntax, which will make more clear once we do a few examples. But why is function calling important? Function calling is a crucial aspect of utilizing large language models because it significantly enhances their usefulness. By enabling function calling, LLMs can interact with a number of user-provided tools extending beyond their native text processing abilities. This allows them to perform specialized tasks like API interfacing, data analysis, image generation, and web browsing directly in response to the user queries. Such a feature empowers LLM to provide more accurate, detailed, and contextually relevant information. This not only improves the user experience, but also broadens the scope of questions that can be addressed by the LLM, making it a helpful tool for a diverse array of applications. Function calling essentially transforms an LLM from a sophisticated text generator into a reasonable engine capable of handling a variety of complex tasks seamlessly. I hope this is clear. Let's go and see why do we use Raven. Now, not only is Raven good at function calling, but it also provides reasoning on why it issued those function callings to justify the calls it has issued. This includes connecting the arguments it has filled in the function call back to the user's prompt, making the generation more interpretable. Please see the examples below. So let's go ahead and see a few examples. So we open those examples here and we see this. Okay, so let's get started. Let's define some functions for Raven-2. In this cell, we will define 2 functions. A function to get a weather in a latitude and longitude. So given the latitude and longitude, we would get the weather data. And the other function is to convert the human readable city names to the coordinates. So the second function gonna have a look first. So this function, what we can we have defined this is the name of the function. Once we give a city name, that city name is going to be broken up into two parts, and this function is going to return the latitude and longitude of that city. So if we see the description here, so the function description is it fetches the latitude and longitude of a given city name using the map.co geocoder API. So we are going to make use of this API here. These are the parameters. We're going to put the city name here in the parameters, and we are going to get the response. So you're going to use the request library, which you have imported here. We're going to use the request library. We get request.get, and then we put the base URL here and the parameters here. So if response is 200, which means it's a success, if HTTP request gives you a success, then we extract the data in the JSON format, and then we extract the data properly, and we print or return the latitude and longitude here. So LAT-LON, latitude and longitude, and then we give some error messages if it fails. So this is how we have defined a function. Given the city name, we will get the latitude and longitude. This is not function calling. This is a normal function which we have defined, and the LLM is going to use this function. Okay, so the second function, or the first function that we define, is given the coordinates in the form of a tuple. Okay, given the latitude and longitude of a location given in the form of tuples, we extract the weather data. Now once we have given the coordinates here, we extract the latitude and the longitude here. Then we go to this API. This is the API openmeteor.com v1 forecast, and these are the parameters. We put in the latitude, we put in the longitude, and we put in the current. So temperature at 2 meters level, wind speed at 10 meters level, hourly temperature, relative humidity at 2 meters level, and wind speed at 10 meters from the ground. So we get the response using HTTP GET request, and if it's a success, then we print this out. So I'm gonna run this, and this notebook was not authored by Google, but yeah, I trust them. So I run this and I run this. So now we have two functions loaded up, and it's ready for the Raven to use those functions. Now let's move on to the LLM part. So we have defined a prompt known as the Raven prompt, and this is an entire text, okay, starting from here till here. So this is a prompt, and there you can see we have defined two functions. So this is a function which has defined the name of the function and just the arguments of the function and the working of the function. Note that this is the most important line, because this is what the LLM is going to read. It fetches, so it's going to read the function as it fetches weather data from the OpenMeteor API for a given latitude and longitude. Now this syntax is very important. We need to give in this syntax where we have the function name, the arguments, the working of the function, so that the LLM can decide when to use the function. So if a user comes up and give the coordinates and asks for some weather data, then LLM is going to use this because it has already read this instructions, and it will be able to correctly identify that we need this function to use to get the output or to get the response that the user is asking. Now another function that we define is we put in a city name and then we get the coordinates. Okay, so this is a different function. Note that we have not defined the actual working of the function. Okay, the actual function, the APIs and everything are already declared, and we have two different functions already defined. Okay, and what we are going to send to the LLM is just this part, just the name of the function, arguments, and a small description of what this function does. So we are going to run this. This is just a Raven prompt. This is a text. And then this is, let's say, a question here. What's the weather like in Seattle right now? So we have the question here. Now we need this API, which is the NexusRaven nexusflow.ai. This is the URL to which we are going to send a request. We are going to send a post request. Now these are the headers we need to put in application/JSON. Now we define a function known as query, put in a payload here, and this is going to go ahead and post and send a post request, HTML request, and get the response and return the response. Okay, and this query Raven is, we are going to go ahead and put the prompt here. So query Raven function takes in a prompt and it goes ahead and constructs this. We make an output. The input is the prompt here, and these are the parameters: the temperature, stop, max new tokens, return full text, and this is the output. Okay, we strip the output, replace, and actually we get the entire naked or raw output using the query Raven. Now query Raven with reasoning, here we are not going to put the stop here. So we are using stop here. We are not going to use stop here. This will give you the reasoning as well of the Raven output. So you are going to have the output first and then the reasoning why the LLM chose this thing or this function. Okay, so we run this, we initiate these three functions, and then we initiate this. So we have, my question was Raven prompt dot format query is question. So as you remember, we have, this is the question: what's the weather like in Seattle right now? And then Raven prompt dot format is, you go ahead here to here, Raven prompt is, you can see this inside the curly braces, we put in the query. So we are putting the query of the question in the Raven prompt. So this is the, my question is a final prompt, and we are going to send the prompt to the query Raven. So once we send this to the query Raven, this is going to go ahead to as input, and then we are going to go ahead and call this function, which is the query function here. So query of payload. So payload is this entire thing that we have here till here. So we put in the payload and we get the output here. This output is parsed and we get the result. So we are running these two for now. Now once we run this and see the output, we see that we are using this complex or compound function here. So you can see that Raven's call, or the output of the LLM, is this. The output of the LLM is get weather data and the coordinates, because get weather data is the function that we have already defined. So this is get weather data, and when we say get weather data, we need to put in the coordinates, but we don't have the coordinates. So we'll get the coordinates. So for getting the coordinates, we'll use another function, which is get coordinates from city, and you're putting the city name. This itself is a different function. Okay, so this is this function, get coordinates from city and city name. So first and foremost, we are going to process this part. We actually define that this is Seattle. We were able to parse that this is Seattle. You're going to pass in the Seattle here, get the coordinates in the form of tuple, pass those coordinates to get weather data function, and get the output. So much so I said, but let's execute this. Now this is what the Raven function gave you the output, but let's execute the actual output. Now if you execute the output, we would see that temperature is 16.5 degrees Celsius at Seattle right now. Okay, so this code is used to execute the output from the Raven's call. Okay, so how do you like it? It's pretty awesome. Now another thing you can do is that you can call in the query Raven with reasoning here. So we have this function. If you call this function, it will not use any stop command here, and if you don't use any stop command, then this is going to give you the reasoning of why it chose what it chose. Okay, So let's see the output. So Raven call is, we have already seen there's a Raven call, and the thought process. The function call get weather coordinates, get coordinates from city Seattle, answers the question, what is the weather like in Seattle right now, by following these steps. So get coordinate from city. This function fetches the latitude and longitude of the city, Seattle, using the map.co geocoding API. And then another function, this function call fetches the current weather data for the coordinates returned by the previous function call. And therefore this function answers the question, what's the weather like in Seattle right now, by fetching first the coordinates of the city Seattle and then fetching the current weather data for these coordinates. Such an excellent and powerful tool to be used in your model. Now I'm going to paste everything. Now it's your turn to try these samples and try this out and comment if you were able to understand function calling at its base. And now you can use function calling for any LLMs if you define it properly. For any LLMs it's possible, but some of the elements might hang and give you a different results. But normally I've seen that with Mistral it's giving perfectly fine results. So this is function calling. This is NexusRaven-V2. Subscribe to my channel and I hope to see you next time. Bye.